Alright, I think we're live. Oh. Blossom, did you run out of here or did you go somewhere? Sorry, my cat's acting weird. Anyway, hey guys, this is SharpZ, and today we're actually going to be trying to get a lot done. Because I have been mainly working on the scripting side of things, and I'm kind of in the mood to do work on the actual game itself. So before we do that, I just want to hit play, make sure that we can actually test it, because every once in a while, through things like updates and all that, no matter what engine you're working with, you will see glitches and... Alright. Yeah, so everything seems to be working. Now, what I am going to do is I want to do something with this weapon object, and that is I want to remove it. So what I'm going to do is I'm going to go ahead and go to my character controller, and I'm going to, just to make this easier, Control F, harmonic, direction equals point direction. Wait, okay. Harmonic change array is right here. Alright, so we're going to remove the direction here. And what I'm going to actually do is I'm going to go into the harmonic system, and I am going to start by making some code for our harmonics. So, harmonics, and we're going to go into our base object right here, and we're going to go to create harmonic variables. So I'm going to make two categories here. So we're going to have what I like to call the attribute variables, and then we're going to have our integer. Yeah, let's just keep these attribute variables. So element, state, damage, cost, AOE variable, time equals time, timer equals blah, 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 team equals team, harmonic speed equals harmonic speed. So we have a speed setting, but what we need is we need to go ahead and go into our steps setting, and we're going to go ahead and put one called define movement var. And so I'm going to use the same language that we use on the characters. So HSP on creation, we're just going to say HSP equals 0 and VSP equals 0. So we're using the exact same code that we are on the player. Define our movement var, y equals y plus VSP x equals x plus HSP. So we're going to actually edit harmonic speed here. So we're going to have harmonic speed x and speed and har speed. Alright, so we need to do something with our player variable here. And there are actually multiple ways to do this. So if we go into our controller, we're going to make what I like to call our facing variables. So facing variables are usually based off of your very basic move command. So if I go into our movement controls, so universal movement, you see how there's the y equals y plus bsp, x equals x plus bsp, hsp equals walk sp times key down minus key up, key right minus key left. So facing equals your sign of HSP. So that is going to give you a negative or positive, and we're going to make this one our, I think facing is already set here. Yeah, facing. So what we're gonna make is we're gonna have V facing and H facing. So H facing is gonna be the one we currently have in there. So let's see here. Facing equals H facing times sprite scale. So that way we know that it's going to flip the sprite horizontally based on what direction you're going. So that one's kind of standard. And what we're going to do eventually for the up and down is we're going to have it replace it as well. But with that, that's going to be kind of another day. Because I don't want to waste time making sprites right now. So we have our facing ID. H facing equals sign of HSP, and V facing, that will equal your sign of VSP. So let me go ahead and explain how this is going to work. And I feel the best way to do this would be to go ahead and I just need something like let's go into Paint, because this is probably the easiest way to explain it. So ignore the wonkiness of these lines. So for example, if you have a 0 right here on both axes, that's going to be right in the middle. Essentially what we're doing is the same thing you'd see in algebra. So it's going to be that XY chart. So up at the top here, let's say we go over to the side. So over at this side, it would be a 1. Over here, we have a -1. Up here, we have a 1. Granted, these numbers might not be exactly how it is, and I'll just fiddle with them to get it right. But what we can do is we can say to check both of these variables, or so for example, if these both equal -1, it's going to mark right here. If these both equal 1x -1, it's going to mark right here. However, if you're only doing 1, it's going to hit one of these. And if you don't have any input, I don't know what I'm going to do with that yet. Probably just default it to forward or something. But since stuff's going to be directional, what we could also do is define these variables like this: 1, 2, 3, 3, 4. The reason I'm untying this from that directional system is this way we have more control over it, number 1. And number 2, while there is the freeform movement, I think I would prefer for it to be an 8-directional movement, 8 directions for your attacks, because that's the same way the movement's going to work. Mainly, if the movement isn't full analog, I don't feel like the aiming would fit being that. So, for example, if we go back to where we were here, these are all your facing signs, and x scale equals, okay. So it's your controller event. Alright, so actually, let me go ahead and check this. So I want to make sure that everything is still working before I go any further. So hit 2 to control Symphonia. Our animations still work. Yeah, essentially the reason I added that HSP1 is what we can do is we can change it so that when she's walking up, that sprite will change. And I would say make it so that if it's 0, then it's just gonna outright turn her back around, because I want the characters facing the camera as much as possible. But what we're gonna go ahead and do is I want to go ahead and take this back to O controller, and we're gonna go to our harmonics code. Okay. With instance create layer instances current harmonic team equals 1, and this is where we can actually get to work on it. Let's go into our harmonics right over here. I'm going to go ahead and X these sprites out. Variable, and then I'm gonna go ahead and turn sys. Alright, so so let's see here. So what we're going to do here is we're going to go global turn equals 2. Alright, so what we're going to do here is we're going to go back to chorus, and we need to find a way so that this will read whatever chorus is facing. Actually, what we can do, there is an easy way to do this. We're gonna go ahead and copy this, so control C, O harmonics, and let's see here, control V, key up, down, left, right. Actually, excuse me, we need these upon creation. And what we're gonna do, we're going to go into the harmonic space right here, and we're going to go into our controller. So its horizontal speed will equal har underscore speed times the sine of key up minus equals the times sign of key right left. So this will do this upon creation. Up minus key down. And let's go ahead and gonna go back into our harmonic variables here. We're also going to do something with this range setting while I'm thinking about it. So with range, essentially what we're going to do is if the x goes up or down by 1 or 2 or whatever, then if the x changes, it's going to subtract 1 from our range variable until it eventually runs out, and then it will set the HSP and VSP to 0. And then we're going to have 2 right here. We're going to have our saved underscore HSP and saved VSP, and both of these will equal let's just do equals 0. And if I go into my steps here for controller, what I'm probably going to actually do for our enemies is I'm going to remove this, I'm going to extract our enemy code and our enemies from this controller and kind of give them their own. So I'm still going to keep the movement control, but I kind of want to, I don't know, I'm still thinking it through. So F equals har speed, save HSP equals HSP, save VSP equals VSP. And then we go into room, menu, harmonics, and here we go. VSP equals saved HSP equals saved VSP. Wait a minute, there's an easier way to do this. If I go into my controller object, I actually just added a step that I do not need. Save underscore HSP and saved underscore VSP. All right. At line 24, that's my issue. Wait, did I saved underscore HSP. Let me go into the fire one here and see what we have in our variable definitions. Wait, Oh, that would be why, because our harmonics doesn't have a defined speed. So let's fix that, shall we? Variable definitions, and we're going to add one. Oh, no, har speed equals 10. Step 0, line 8. Wait, I probably mean error on O controller. O controller. Did I just do something stupid? Weapon. Harmonics. Okay, here we go. Wait a minute. There might actually be an easier way to do this. So if I go into our controller command, step, I'm going to remove the turn change, because I feel like what's happening is it's changing the turn. Let's see what exactly is going on with our... Oh, we need to work on it for the enemies. That is why. Okay. So, harmonic. Self equals we're going to move to the direction and speed code here. Alright, so equals r underscore speed times, wait, oh no, it will be saved HSP equals har speed, and that would be multiplied by some more brackets. So everybody's favorite part, we get the parentheses out. It was har speed times minus I want to make sure I do this. minus instance nearest its own x and y O player O playable. So it's going to target the nearest O playable. Minus the playable dot x. And then saved ESP equals par underscore speed times y minus nearest instance nearest x comma y playable dot y. Yeah, you need the sign of all that. Team. Yeah, there's a very simple fix. Just go negative, and watch. That will fix it. That will literally fix everything. The only issue is okay, so I need to go ahead and I need to make sure that the let's go back to that player control for the harmonics, and see, the easiest way I find is just put a negative sign, because you could reverse how those two are added and subtracted, but it's not going to make too much of a difference. Water. So we can add more to this array, and what it does is that, okay. But say that we want to just do a standard attack, that's what we're going to work on next. So attack, and what is our attack key? I want to say it's space. Gonna take the weapon object here, and I'm just gonna go ahead into our room here. I'm gonna go ahead and delete that because it shouldn't be tied to anything anymore, so we don't really need to we're removing that. And I'm going to do something here. So check released. Yeah, now it checks if you're released. Okay, harmonic change array. Alright, one more thing I am going to actually do is we're going to go into the players here. Excuse me, we're going to go into controller. I'm going to do one more key input definition right under our movement keys, and this is going to check if we have any press down. Just going to go variables, and then no key equals, it's going to by default equals true. If up and no key down, and no key left, if it's in our universal movement control, yep. Equals walk SP times key down minus key up. What I'm going to do is I'm going to add a little UI element so we know what we're shooting. So I'm going to go ahead and do something into our sprites folder, and we're going to create a new sprite here, and this one, let's go ahead and edit the image. I'm just going to make a very basic arrow. Let's change it to like a bright red for right now. Grid it. And then the next side should be a good 32. Ooh, that right there, that's about what we're looking for. Yeah, and then I need to, let's do a red, and then I'm gonna go ahead and turn the grid lines off. And let's go ahead and S arrow. And we're going to create a new state here. Control equals true. And what we're going to actually do here is we're going to do something very simple. We're going to create a new key to hold. So let's pick, trying to think what key would be good for a hold. Q, I guess. key hold equals check board and this one I'm gonna go with Q. I just feel like that's the one I want to go with for this particular one. So if key hold HSP equals 0, VSP equals 0. So this one's a fairly simple one. So what it's going to do is it's going to read, if we have the key, the held key, put up. You know, I'm going to change this to something that I can more easily hit from the space bar. So let's do M. M up. And if you release it, you can just move around. All right. I need to check one thing while I'm thinking about it too. So the reason I'm adding a hold key for right now is ideally what I want to be able to do is just have the player switch to some kind of an attack menu. But to test it out right now, it's probably easier to have an actual key there. And what we're going to also do is go ahead and make the stamina system while I'm thinking about it. Okay. So we have our HP max, MP, def, ATK, range equals range. All right. So we can go from range, and right down from range, we're going to have one called stamina equals stamina, and I'm going to go ahead into our controller variable over here if I can find the. We're going to go ahead and go to variable definitions, and we're going to add a stamina, and by default, let's say that it equals 100. And what I'm going to do is I am going to go ahead over to our stamina variables. And hand control equals true, and stamina is greater than 0. Then we're going to also do if stamina is 0, then it's also going to change the turn. So it will be 0 turn equals wait, let's go. Actually, let me do one thing. I forgot we have, okay, stamina equals stamina max. I'm going to go into a room here, and we're going to go back into our workspace, and we're going to go make this stamina max. Why? Because having it as stamina max rather than just as stamina makes this a whole lot easier. If global dot if stamina equals 0, global dot turn equals 2. And then we're going to go ahead and add the stamina system to both of these. So universal movement if stamina is greater than 0. And that right there is going to be our movement code. Yeah. Alright, so that way it knows to only move if our stamina is greater than 0. And what we're going to do is if X let me do one thing. We're just going to check if the variable changes at all. That's one way to do it, but we're going to have two that are current y equals y actually there might be a better way to do it. Yeah, O center. Let's see how O center works. because I think if I remember correctly with how our O center object works, this one follows the player. But what we're going to do here is we're going to go into where it has the range, and we're going to actually make range and stamina kind of the same thing because they're both going to rely on the same variable. So what it's going to do is it's going to check we're going to start by going actually to our game rules. So if we go into step here, enemy turn switching, if player start equals true, this is a series of that's our turn timer. Actually, what we can do is we can do this on turn 2. So if global.turn equals 2, start underscore x equals x, start underscore y equals y. So what we're going to do here so if our turn equals 2, all right, and then it's going to be if start underscore x right, and let's just make one here called move underscore amount moved underscore space. And it's going to be right here under visual. Okay, we're just going to put this under. Let's do this one under our movement. And move underscore moved space equals 0 by default. Moved space equals the sign of x minus start x equals, absolute value, excuse me. So what your absolute value is that returns a positive number, regardless of whether the number initially is negative or positive. So for example, the reason I'm doing that with this is, let's say that our x is 46 and we move down to 45. So, excuse me, our starting x is 46 and move down to 45. That way this would give us back a 1. And vice versa, if our starting x is 46, if our starting x is 45 and we move up to 46, it would still be 1. So, equals the absolute value of all that plus the absolute value of y minus start y. The order of those two variables does not matter. So, that's our moved space, and then stamina equals stamina max minus moved space. And I'm going to also go and say that stamina equals stamina max. So actually the reason I'm putting a stamina system in is that's, I feel, a better way to control our movement. So let's say we move. Oh, these aren't. Copy. Okay, let's put these upon creation and go that when they're created, it's also going to equal them. And then we're going to go if stamina equals 0. Let's just go ahead and say HSP equals 0, VSP equals 0. So that way it will just stop the character outright, and I think stamina will be watch, yeah, because you can still fire and all that. stamina equals 0. Let's go into the harmonic array, really, into our workspace and actually do something with that harmonics variable. Excuse me, with the game rules variable. So with our game rules variable right here, essentially what this is going to, what we need, no, not game rules, excuse me, controller variable. So if we go into our controller variable, map sprite scale equals 1, stamina max equals, let's up that by 1, 0 and see if that doesn't change things. If global turn equals 2, all right. I wonder, is stamina messing with something in the system? Did I remove the turn timer? Because that would do it if it's the oh, that would be why. Alright, so let's go ahead and let's erase that from here. So it's only reading that movement if you can control it. So if we go to right here, and then we go that way it's going to set that if the turn equals 2. So let's go ahead and yeah, that fixed it, I think. We're going to need to work on enemy AI later, but let's see here. So we have a good amount of stuff in here. So character selections in here. Now what I want to do is I want to make sure that when you So what we're going to do to make this system flexible is I'm going to actually go into game rules. And it's going to by default, let's just say global dot player count equals 2 and global dot controller count equals 1. So controller count is going to be what we're going to use to add in multiplayer down the line, but right now player count's what we're going to focus on. So upon step, we have enemy turn switching here, but we're going to add something down here that's not linked to any turn. So global dot player count equals instance object get physics, oh it's right visible, object equals, let me check something. Because I think I remember what this does. It's just alright, yeah. Instance number O playable. And what we're going to do here And let's go back into our game rules thing, and I'm going to do something with our turn count. You know what, let me go ahead and actually open this up in full screen. That will make this a little easier. So create controller count equals 1. That one we don't really need to worry about. Player count equals the instance number of O playable. And global dot units ready equals so units ready will equal 0. Turn 1 global dot turn timer minus global, if it does not equal 1 dot, we're going to do this on player we're going to go if global dot turn equals 2, global dot units ready equals 0. So now when it hits 2, it's always going to reset that variable. And we're going to do something here. So what I'm going to do is I'm going to organize this really quickly. So turn timer. Go ahead and Control X that. And right here we're going to have our, I'm going to call this the unit check. And here we go. Global dot turn equals 2, units ready equals 0. Creation. We're going to do something over here too. Global dot enemy count equals, let's say by default it's going to equal 0. Just because if it equals 0 in an area, global dot enemy count equals instance number O enemy. There we go. So that way we have our enemies on a separate spectrum here. So what we're going to do is we're going to have and it's going to say here if global dot turn equals 1, since that's our player turn, global dot player count 1 and global dot units ready equals dot player count. We're going to go with turn global turn equals 2. The reason all these variables are going to be global is because with all these, when it's referenced, I want it to reference that specific one. So global.turn equals 2. Let's go into our controller here, and I'm going to find where we have our harmonic variable for the player. Current harmonics scanner task. Well, actually what we're going to do is we're going to start tying turn count elsewhere. But we're going to do a global dot units ready plus plus. And can underscore move equals true. And what we're gonna do here, let me check here. I think this covers like half of our it goes like all the way down to that enemy code. And we're gonna say by default our can move equals true. All right, and then we go in here, and what we're gonna do is with our harmonics, one, and let's just say can move equal false. And we're going to add this to the turn 2 thing. Can move equals true. So if I calculated it all right, what should happen is we move chorus, if can move equals false, HSP equals 0, VSP equals 0. All right. See, and we can't move him, but if we go to move Symphonia, we should be able to. Yeah, we're gonna, so with the player switching, what we're gonna do for this later, just since I mentioned the controllers and I want to kind of give a good idea of what I'm talking about when I say this, we're going to tie these variables to that controller variable. which is actually not the hardest thing to do. It's just kind of a bit of a chore, and we're going to add controller support eventually. It's just that right now I want to really focus on trying to get that core aspect of the game. Now, one thing that I think we do need to work on is our enemy AI. So I'm going to go and do something that I wanted to do a bit ago, but did not really get around to. So, enemy code, let's see what we have in our controller code. So if we go over to our controller, step is get inputs. What we're going to do is we're going to go over to our enemy object. And we're going to add a new step event at the end step. Now, granted, this means that we'll do it second. So, if global dot turn equals 3. And what we're going to do here is we're going to go ahead and set our variables that we are going to use for enemy AI. So at the top right here, I'm just going to put enemy AI. And for starters, I need to see if I can't do and inherit event. If we open this creation. And then we can go, yeah, if you inherit the event, you can actually add more below it. So, unique AI var. So what this allows you to do is this allows you to make variables that are going to exclusively apply to the enemy subsect. And let me make sure I'm telling you right here. Let's go ahead and close these brackets first so it will actually let me start the game. But if you see here, it's still gonna, the enemy is still gonna react how they usually do. Oh, yeah, I need to. Yep, see, they still shoot fireballs and all that. So, what we're going to do with this global turn variable, and what I'm going to also go ahead and do with the step here. This one. Sorry, I heard a banging on Is she, my cat probably hit on her here. Hey Blossom, you okay? Sorry, wanted to make sure that cat was doing fine. Started banging on my door, probably my neighbor going in. But anyway, global turn. So our unique AI variables are going to go below this. So, what I like to do is I'm going to go ahead and, actually I think the easier way to do this, let's go into our controller variable and pretty much find anything that is unique to the enemy right before we're going to do this. So if we go over to our inherent event, and let's go to our controller event. Step, and let's see if we can find enemy. If enemy equals true, stamina equals 0. Pretty much what I'm going to do is I'm going to cut pretty much all of our enemy code. Control X. And we're going to go over to our enemy object. I'm going to go into our our steps, draw GUI. It's a workspace, okay. What the heck's going on over there? I'm just gonna close the door really quickly. Alright, so anyway, what we have here is a few step variables. And I always check after I do this, because if you cut the code out, you want to make sure you didn't accidentally spaghetti any of it, which, for those of you who are unfamiliar with what that means, spaghetti code is kind of a slang term in any form of code for code that you make that intertwines in such a way that it is hard to separate it from anything else you're doing. Yep, he's good. Alright, so we can actually take all of this and we can edit this. So what we're also going to do is I'm going to go into, I like to keep the enemy variable and all that. So what we're going to go ahead and do here is I'm going to actually take this and first let's do that. So we have our, let's remove the end step of that. So if enemy equals true, stamina equals 0. Alright, so upon creation, what we're going to do is we're going to have a few unique AI variables. So let's just say charger equals charger. What I want to do, actually what I'm going to go ahead and do is I'm going to go into, I have a document with my game design stuff. So we're going to open this Google Drive doc, and this will probably be our best way to do it. What I find the best way to work on AI is let's go to recent. CS3 Prize Game Design Doc. There we go. Okay. Do a battle system to player characters. Strength comes from interplay, yada yada. So if I want to make sure that I don't already have some kind of AI outlined in here. So your AI ally enemy. Let's go ahead and look at make a few types. So reason I say that I like to make my AI and what I call types is that allows you a lot more versatility. It gives you the ability to on and off switch it, and it kind of makes it, I feel the best way to make your enemy AI is one that fits with the game, but one that you can also very much control and shift if you need to. So I would say the types that I want to make for this one is we're going to have the charger. This one will focus on physical, melee attacks, charge the player. And so both of these are going to act pretty much the same way. So it's going to focus on the melee, charge at the player, yada yada. But we can, if I try to remember correctly here, the other thing that we can do for a charger is we can just have it say, since we're not going to be able to do some of this until later, but one thing I do want to add into these is kind of a smart targeting system. So with some of the enemies, they'll know who to target based on if my skill set has any elements that this character is weak to, or if this character is guarding, I will try to run around, stuff like that. So you have your chargers. These are going to be kind of your very grunt-like enemies, the ones that you can take out fairly easily. We're going to have rangers, which these ones will try to space themselves from the player and focus on ranged harm harmonics or other weapons. And then there's a few more that I usually like to add, and these are gonna kind of be their own unique thing. So these are your tanks, which the tanks are going to kind of, what they usually focus on is just space control. So these characters are going to be your standard patrolling units who they'll notice the player and they'll charge at you, but they're not really there to kill you. They're more so there to... Actually, yeah, no, tanks doesn't make sense. Excuse me, what I meant to write was you have your healer. So pretty much I'm following what the RPG triangle is that a lot of people refer to. So if you have your healer, you're kind of... Once again, they have their space themselves. But they are going to focus on healing allies, and they cannot be, and they will actively avoid battle. And then there's a few, I'm trying to remember a few more. Oh yeah, tanks. I can still put them in somehow. These ones will focus on guarding and I would say low player target range. Because with your tanks, what I want to be able to do with those is make those kind of a thing where it's like you see one of those enemies, you're like, oh, shoot, we have to work together and actually take them out. So the tanks are mostly going to be your own thing. And then, of course, you have your boss AI, which I'm going to just put a note here, and this will say unique based on bosses. What I'm thinking about for the bosses is kind of making it a mix of your bullet hell mechanics with this basic harmonic system. Because the thing is, with how the enemy AI and the player AI is working right now, it is very much the enemy shoots at you, and then it doesn't really know what to do from there. Your NPCs, like all these AI, some of these are going to have, let's just say that these are your fighting types, and then you're going to have something down here where I like to call your, actually, yeah, I forgot one. So these are going to have your guards, which these are going to patrol and can alert allies fairly easily. So the issue with having too ambitious of an AI is if you go overboard. If I were to list all the details of this, then that doesn't really help me too much. What we need to actually do overall with this AI really quickly. So for the enemy AI, let's go ahead and make one thing here called what we need. And so first off, we need pathfinding. So I would say this one is very specific to what we want, how smart we want the enemies to be. So since this game takes a lot from strategy RPGs, the question ultimately becomes, and I'm going to go ahead and I'm going to, don't save that. I'm going to just go ahead and Microsoft Paint it, and I know that some people are probably like, why do you keep using MS Paint? You have paint.net. Look, I just don't feel like pulling it out. So let's just say this right here is your wall. So let's say you have your player right here. Now granted, there are some enemies that you might want, I'm going to make the enemy red just so I can easily showcase this, and then we'll go with a blue line. So if you want you want the enemy to patrol, then it's just going to stay back and forth here. But you might want the enemy to know to go around here. You might want an enemy that will try to go behind and flank you. Because it's the thing of, you're going to know what's behind these walls, but due to how our current AI system works, essentially what it does is it draws a line between the enemy and the player. And it checks for if there is a wall collision. So the enemy cannot see the player if there's a wall there. However, what we can try to do is make a system where the enemy either A, can see if another enemy, so let's just put another enemy right here, which this one is one that I'm probably going to try to do just because that is probably what makes the most sense and will incentivize taking out enemies the quickest. So let's say there's another enemy right here and he can see, this one can see, ignore the fact that there's like this one can't see you, which that would just feel weird because I mean you would probably figure, hey, he can see me. We're gonna add one more enemy into this. So let's say that what we have right here is we have an enemy right here who can see you. So these two right here, they cannot see you because of the wall. But this one right here, he can. So what my idea is that there's kind of going to be a communication system where it's this enemy's going, what they're going to do is rather than trying to pathfind to the player directly, this guy is going to essentially send a signal out of, hey, I can see the player, so let's just say our variable will be C. So this one right here will see the player, and then these two will have a kind of different reaction to this guy, where this one will say, which enemies do I see? So let's say he will see this guy. So instead of, if this one sees the player, it's going to give off like a signal. So let's say it gives off a 1. Then this enemy will react to this guy, not in the same way with the player. Like, it's not going to attack him, obviously, but it's going to know, hey, I can come down here, and then if I see the player, I can attack them. But he's going to send essentially a signal out to both of these other enemies right here. So, but his C signal is going to this guy and that guy. See, the only issue is the only issue with this is it's going to take up a lot of memory space. If, say we have let's put another wall here for just the sake of explanation. So let's say we have another enemy here. What we're going to do is we're going to say this guy right here. The issue is it becomes inefficient because what you see eventually is, instead of this enemy just saying, hey, I see the player, and then what I'm probably going to have it do is give some kind of it's going to give coordinates to this spot, and then they're going to draw a line from where they are to said spot and see if, hey, it's either going to be, hey, there's a straight line walk, or better yet, what I'm probably going to actually have it do, let me go ahead and Control-Z this. What we can have it do is we can have it draw 2 lines. So one like that, one like that. Oh, you want to get out? Sorry, Blossom. Sorry, I can't. But let's say we have 2 lines. What we can have it do is we can have it say, well, I can't go this way, so I'm going to keep going this way, and then at the end of every frame, it's going to continue to check, hey, can I start going this way? So it's going to essentially we're going to put a kind of like a placeholder variable right here. So it's going to say, oh, I saw them at these coordinates, and then they're going to all try to pathfind to said coordinates. Now, let's go into our step and event inherited. If enemy equals true, there. It has that same. What we're gonna do is equals true if global can attack equals true if place. So let's just put this one as our. Actually, I just realized something that we do not need on this code right here. If we go over to where it says. Since it's already in like our essentially our enemy object, so what we can do here is we can go to our enemy. This also part of the reason why I separated it to a different object. This way we don't have as much code that has to run through the player, so it makes it a little more efficient. So if enemy equals true, we can go ahead and delete that. Let's just check how far down it goes. Yeah, I think. And I'm going to go ahead and X out those and see if, so if I hit, let's just put, we're going to call this the turn events, attack equals true if global.turn does not equal. These are both redundancies, so I'm going to go ahead and actually merge these here in a second. Yeah, just delete both of those. Sorry, this spacing is going to bother me if I don't do anything about it. And enter that. There. So if global.turn does not equal 3, can attack equals true, HSP equals 0, VSP equals 0. If place meeting, yeah, this way it just knows not to hit the, it does not move at walls. So I'm gonna take that and we're going to take our collision code here. So Control X, and if place meeting X plus 1, this will be our collision. And this is why it's important to do this early on, because so let me go ahead and we're going to actually make this a little more complicated than it was a few minutes ago. So what we're going to create here is we're going to create our targeting system. Now, what I want to do is I want the enemy to prioritize which character to attack by who is visible. So, rather than what we're gonna do is if object exists, O playable. And let's say just by default, actually let me check the creation code in our controller. In the creation code it says that there is no target. Okay. Go into the room code here then. So in creation, let's just say target equals self. That way, I guess target equals target will work too. Equals O playable. There we go. That might be a better idea. So if object exists, O playable. So we have what we call collision lines. So there's collision lines, collision pointless, and collision rectangles. So what a collision ellipse, collision circle, collision line. So what pretty much all of these are is it draws an object. It's an invisible object, but it does draw one. And it will check if it collides within that specific shape. Let me see here. Yep. Collision ellipse, collision circle. And what I'm going to do is I'm going to say collision the target could equal the nearest instance, but what we could also do is say and let's see here, C player equals, and let's go ahead and categorize these. So we have here our targets, AI var C player equals false. So these are going to actually be changed in the code itself. What I'm going to do is I'm actually going to go ahead and Control X that, and I'm just going to I don't really want it in here right now, so maybe what I'm going to do is take all of this, Control Exit, put it into our, I like to usually make a little document here just called code reposit, and here we go. So our code's saved here for later, but right now I want to work on this. So it's going to check if there is a collision between these walls. Equals 5. So let's see what it does here. So what it should do is check if either playable instance is within its line of sight. All right, so yeah. I could have it essentially draw a line between it, but I feel like what the better solution would be so here's the thing. If we one way that we could essentially do this is a grid system. I'm gonna go ahead and don't save. So if we have like a grid, and let's say, yeah, let's say that's our grid. If we do that, it's not gonna let us do it like that. But gonna put our enemy right here, and we're gonna put the wall right here, and let's put, so what we could do is we could have it, oh wait, no, that's another enemy. Playable character 1's right here, playable character 2's right here. So if we I think what it does is it defaults to checking whichever the closest one is. So that's your issue. It's going to check if this one is for this one and completely ignore this one. Now what we could do is we could say check within a square or ellipse area, but our key issue with that is how exactly do we define it? I mean, one way we could do it, if I remember correctly with how the, let's see here, collision rectangle. Alright, so it's going to check if anything collides within it, if I remember correctly. So I think what we should do is actually just scrap this and make a collision rectangle. Alright, so we're going to add a few more variables here. So sight line equals sight line. Let's set it to 100 right now. Well, essentially what I want to do is I want to make it so that it's going to have a rectangle in front of the enemy that it draws. Essentially like what you see here. Let me go ahead and Control-Z that. So let's just go with that whole vision rectangle idea, and what I'm going to do is I'm going to draw it right here just so we have an idea. So let's say it's going to draw essentially a vision rectangle and just stop right here, and then maybe it just goes to like right there. That way enemies cannot see behind them, but you can still check if characters right here, or it will only go to like right here or right here. But regardless of whatever way they're facing, it's going to take their facing direction, and that is going to be where it goes. So like if you have an enemy like down here, what you can do is you can grab the square. What it's going to do is it's going to be looking this way, so I would say maybe just widen it a bit. So this would be like your vision for this enemy, of like they can see in this direction. And then maybe if they're out in the, because the issue is if they're out in the open like this, everyone's going to question why they can't see you. So I would say maybe also make specific rectangles where it's, you know, if it's like an open floor plan, it's kind of a stealth zone thing. What we could also do is add add stealth zones into the game. So rather than it reading if an enemy can see you based on, we can. I think mixing the two might honestly be the best option, because if we have a stealth zone option, then we could say, yeah, everywhere within this rectangle, he can just see naturally. But if you step outside of this like rectangle area, and you're still in this, then he's still going to go after you. But this way, this enemy knows, hey, I'll go over this way. Or what I'm definitely going to do is say if an explosion or an instance of harmonics exists over in this direction, some enemies will know to run toward it, whereas others will just back away. So it's an interesting system to work with, but I think what we need to do is start with that rectangle. So let's start by going into our object here and see where we have our facing variables. And that's actually part of why I did this today, because I thought this would be visual h facing equals 1, yada yada. So universal movement, and let's see here. Turn. Face. Facing, h facing equals sign of HSP, v facing equals sign of VSP. Equals the sign of HSP if let's just go if HSP does not equal 0. These are fairly easy ones to go. So, and then this one's just going to be if VSP does not equal. Oh yeah, I don't know if I mentioned this yet, but those exclamation points are essentially telling it not. So it's saying instead of if it equals, check if it doesn't equal. So like if we were to do this, then I would say we have does Symphonia just turn the other? Okay. Yeah, the stamina system is going to kind of be pulled for the enemy as well. But let's go ahead to the enemy commands. Equals playable. So it's going to draw, excuse me, collision rectangle. So the first x and y is going to be its x and y, and essentially what I want to, yeah, with how the rectangle works, it's going to draw two coordinates, and that's kind of our issue, I just realized. So collision, let's see what other kinds of collision we have. Collision circle, collision point, collision rectangle. Oh, you probably don't see her, but my cat's being a little weirdo again. That's why I love you, blah blah. That's why I love you. Oh, does she finally notice that box? Oh. I'm sorry, she's my favorite part of the video. Anyway, I need to put it on the charger actually, just so. Yeah, believe it or not, I actually have a light inside of this. But yeah, if we are continuing to work on this, what I think is really necessary is we need to figure out how we're going to do this in the AI, because that's going to be the hard part, is how do we tell it I know I have a whiteboard in here, but I don't think that's going to really help with this explanation, so I'm just going to open OneNote, because this has probably the best tools for this. So let's go to concepts graph. All right, untitled page, and we're just going to call this AI. So I want to consider all our options here, and then let's go ahead and add row lines, grid line. Let's say a slightly bigger grid line would probably be better. Good. Okay, draw. Now, what I want to do is I want to have our shape. All right, so she found my laundry basket. Oh my word, that is Blossom. She's a sweetheart. Anyway, if we go with this idea, and let's just say this right here is our player character. Here, I'm gonna. That's our enemy right there. So what we essentially want to be able to do is we want to be able to tell it to not find the player over here, but still know to look out here. So I like the stealth region idea. My only... What? This is why AI will never be successful, people. But anyway, if we look out into the distance right here, a vision cone or a vision, whatever type of vision thing you have here, our main issue is when you get into this area right here, what are we going to do about that? You know, like, what if we do stealth regions, then actually, let's try it. So the idea I have is if we make a... We could do those regions, but we could also do a... You know what would actually probably be a better idea? If we have it check for the nearby walls, and then it just draws a square, and then it just will check if it's not behind one of the walls. So if we do a one like that, it's going to check if they're behind the walls. But if we have it draw a line and check if there's to the nearest wall, then we can say, okay, Actually, let me check and see if there's a... So by default, it's going to equal all playable. So collision rectangle. So x1 the instance nearest to its current x, y, the nearest O wall, dot x, I'm trying to think of a way that it will wait a minute. Doing an instance nearest is not the collision line from itself x, y to let's make a formula here. So facing, it's not gonna be, we're gonna make this one right here our let's have this be vcheck equals collision line x, y and it's going to be x plus x plus, and this is going to be another formula, sight line times, so that sight line, that's going to tell it how long to look, times h facing. So if it's wait, okay. Then we still have a y2, so for that one it's going to be y wait, let's see what other shapes we have. Wait. Okay, I think they probably have a collisions. Alright. Place free, instance place, instance position, instance place list. So that's a point in a rectangle. Collision rectangle. Yeah, let's see here. So it's going to start right here, essentially, and I'm trying to think here. It's a collision point. Yeah, a circle is going to be based off the radius. Actually, what we could do is we could say, let's just call one of these a collision circle, its own x, its own y, and then the radius is going to be what's drawn from that specific x or y. Equals sightline object equals playable precision. Yeah, I would say this is a false. You don't really need the best collision for that. And then not me would be false. So say target equals, so it's going to check if there is a collision within that sightline first. Essentially what I want to do is I want to have it, let's just do enemy communication right above the right. Not me equals true. All right. Target if it's going to check equals true, then it will say C player equals true. Change it from target to playable. Then what it's going to do is it's going to nearest instance nearest x, y, oh, enemy, with instance nearest x, y, o, enemy, it will change its target equals player self. Let's just say if we're gonna have them communicate back and forth, let's just say have it call out equals, by default we'll have it equal self. So true call out wait, I think I did something with this for harmonics. Yeah, because what it needs to do is it needs to call out. What is... Wait a second, I'm going to go ahead and take a look at this. What is path position? Oh, it's a series of actions. Okay. Management, extensions, rooms, instances, sequences. Alright, so table of contents, Gmail, visual, Gmail code. This is what I use, asset management, code reference overview. This game input. Physics, time sources, maths and numbers, date and time, number, functions, angles, strings. No, it wouldn't be a string. Physics. Oh yeah, movement and collisions. See, these are all general. Okay, that actually will work. Game load buffer. Wait, are these new? Give me a second. equals. No, that doesn't get put. Call out equals. Wait, let's change it from call out to wait, okay, let's see here. Alert equals false. Last scene X equals player equals true. Alert equals true. True, and then it's going to wait a minute, yeah, because those variables are all set individually. That's our issue. We just need to pretty much have it we're just gonna put something under enemies, create object, and let's just call this O and then it will with instance create layer X Y O C pin layer IDs in instances OC pin and wait, what's the instance create later? What's that variable structure thing? Oh, wait, so what's the difference between a struct and a O C pin? If if alert equals false, then it will create this. That way it just doesn't keep creating it over and over again. Because that's kind of what I would do. So that way it's just not going to actually, yeah, then let's cut that. C player equals true. Otherwise, let's just say else player equals false. Yeah, okay. So essentially what we're going to also do is we're going to give each enemy 2 radii. There's going to be their sightline radii, and then there's going to be their alert radius equals, let's multiply that. So let's say 300 right now. So else if circle x, y, alert radius O, C, N, precision false, not me equals true. Oh, okay, yeah. Not me equals false. Wait, the instance should be the player, yeah. True. Yeah, so it's gonna check the C pin, and if the C pin first we're gonna say alert equals true, target equals if wait, yeah, let's go. And C player alert equals true and target equals C O C pin. And we're gonna do something here, global if global dot turn equals 3. So that way all this is going to be stored in one essentially massive variable. So we have a targeting system right here. Actually, let's go ahead and maybe we should move this below that, because that way it's, yeah, it would be weird if they at least didn't notice characters when it wasn't their turn. If global.turn equals 3, HSP equals walk SP times the sign of target dot x minus x. It's not all yet. VSP equals walk SP times the sign of get x minus x. So with this, it's just going to check if they're in a specific circle. And if we're going to check the communication, I thought that was in the controller variable. Walk underscore SP. That would be it. Yeah, that's it. Walk underscore. Walk underscore. And hit play now. I'm hoping got Y. All right. The only issue that you get with this is it oftentimes, due to how walk SP works, it's not going to be able to hit that exact number. So, yeah, you see that shaking effect that you get there? Equals true O C pin. And collision underscore circle, and we're going to pretty much do the same thing here. X, Y, sight line, O, walls, false, false, equals false. That way it's just going to check for the walls as well. That just gives it, yeah, OC pin. Then it will so let's say put chorus right there and then symphonia like over here, and oh wait, no, we need to make this one that collision line. Alert radius. Alright, so that's if it's going to check the C pin. Yeah, we're going to need to work to remove that shaking effect at some point. if I think our collision line X, Y, let's set X2 to be playable dot X Y balls precise. No, not me. True. All right. 41. Oh. Oh. Balls. And it cannot see the player, then it's going to go toward that C pin. X. Oh, not me equals true. All right. Yeah, that just saves your memory, because if you don't. Wait a minute. Oh, yep. Equals line 41. If C pin if instance exists, C pin. There we go. Then I'm gonna go ahead and say, it's gonna draw that line. And then it's going to be if that equals false and it does not see the player. not me equals false. Let me just check and see if the change this to if alert equals true. if it is alert. Equals instance what it's probably doing is not knowing to which one to draw to. Dot y. I'm gonna delete this whole C. If C player equals true. I'm gonna get a little bit of caffeine in me, and then get back to work on this one. Okay. Let's cut the target section and see if that does it. I do need to do one thing, and that is tell it that if there is no it's not instance find, it's Oh, position change. Oh, that's going to create a list of everything that's hit. I'm gonna be honest, I think I'm kind of burnt out for the day. But I wanna at least try one last thing. Nearest is X, it's Y, and now playable. If collision line from its own axis. Player equals true. C player equals true. HP. HSP equals OCSP. But why can they phase through walls? What the heck? Just do an else if. Perfect. I'm gonna put him right there. Seriously, why can't he walk through the walls? There. I think that did it, because if we, now let's just move course like right over here. Honestly, I think I'm done for the day. I'm just, yeah.